Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about autocorrelation function of the response y of t and cross correlation function of input and output. In my previous video, we have discussed about mean value of the response y of t and mean square value of the response y of t. Now here we are going to discuss about autocorrelation function and cross correlation function of the response. First, we are going to discuss about autocorrelation function of the response y of t or output y of t. Let x of t be wide sense stationary random process. The autocorrelation function of y of t is r y of t comma t plus tau is equal expectation of y of t plus tau. So this is the definition of autocorrelation function of the random process y of t, output y of t, autocorrelation function definition. So what is the Lti system output? The Lti system output is y of t using convolutional integral. Y of t is integral minus infinity to infinity h of tau into x of t minus tau d tau. So using that definition, y of t is on RHS side y of t is integral minus infinity to infinity h of tau 1 x of t minus tau 1 d tau 1, and second integral is y of t plus tau is integral minus infinity to infinity h of tau 2 x of t plus tau minus tau 2 x of t plus tau minus tau 2 d tau 2. Using convolutional integral definition, we can write y of t and y of t plus tau. So now we are applying the expectation into applying expectation value only the Weidsman stationary random process. We get r of t comma t plus tau is equal integral minus infinity to infinity integral minus infinity to infinity expectation of x of t minus tau 1 x of t plus tau minus tau 2 into h of tau 1 into h of tau 2 d tau 1 into d tau 2. So using definition of the autocorrelation function of the random process, expectation of x of t minus tau 1 x of t plus tau minus tau 2 is the rxx of tau plus rxx of tau minus tau 2 plus tau 1. So that is rxx of tau plus tau 1 minus tau 2. So this value plus tau 1, tau minus tau 2 plus tau 1 into h of tau 1 into h of tau 2 d tau 1 d tau 2. So using convolution definition, the RHS integral term is the RHS integral term is the RHS term is the convolution of the double integral, that is Rxx of tau convolution h of minus tau convolution h of tau. Because x of t is assumed to be wide sense stationary, there are two facts from this result. So that is, first one is y of t is wide sense stationary if x of t is wide sense stationary, because r of tau does not depend on time t and expectation of y of t is constant. That is the first condition. And the second condition, from this equation it is evident from this equation, that is autocorrelation function of the random process y of t equation is twofold convolution of the input autocorrelation function with network's impulse response. So that is r of tau is equal rxx of tau convolution h of minus tau convolution h of tau. So this is the concept of autocorrelation function of response y of t. Next we are going to discuss about cross correlation function of the input x of t and output y of t. So the cross correlation function of x of t and y of t is rxy of t comma t plus tau is equal expectation of x of t into y of t plus tau. So this is the definition of cross correlation function of the random process x of t and y of t. So x of t is the Whitson stationary random process that is input to the LTI system, and y of t is an output of LTI system. So using convolutional integral definition, y of t plus tau is integral minus infinity to infinity h of tau 1 x of t plus tau minus tau 1 d tau 1. So applying the expectation only the Whitson stationary random process. Therefore, the RHS term of this equation is integral minus infinity to infinity expectation of x of t into x of t plus tau minus tau 1 into h of tau 1 d tau 1. So using definition of autocorrelation function of the random process, expectation of x of t into x of t plus tau minus tau 1 is the expectation of sorry Rxx of tau minus tau 1 Rxx of t plus tau minus tau 1 minus t. So now here plus t minus t is the cancel and the remaining expression is integral minus infinity to infinity Rxx of tau minus tau 1 into h of tau 1 d tau 1. So using definition of convolutional integral, the RHS integral theorem is Rxx of tau convolution h of tau. Similarly, it can be shown that the autocorrelation function of the cross correlation function of the random process y of t and x of t is r yx of tau is equal integral minus infinity to infinity h of minus tau r xx of tau minus t1 tau minus tau 1 d tau 1. So which is equal to this integral term is equal to convolution of the Rxx of tau and h of minus tau. From the above equations, it can be concluded that the cross correlation function depends only on tau and not on absolute time t. The autocorrelation function Ryy of tau and cross correlation function Rxy of tau and Ryx of tau are related as Ryy of tau is equal Ryx of tau convolution h of tau and Ryy of tau is equal Rxy of tau convolution h of minus tau. So this is the concept of cross correlation function of input and output.